So today we're going to look at 7.2a. We're going to look at A and B actually together, but I am going to put them in two separate podcasts just so they're a little bit shorter. In 7.2a, we're going to look at multiplying, really in both A and B. We're going to look at multiplying radicals, so square roots. We might have some cubed roots in here. In part B, we'll also look at a little bit with dividing. Now, I just gave you little bitty problems here. What I want you to see is you've got two options when you are multiplying radicals, assuming that they're the same roots. These are both square roots, these are two. So here are your two options. You could take the square root first, so square root of 16 is 4, square root of 9 is 3, and then you can multiply. Okay, so that's great. Your other option is you can multiply the numbers inside the square root. So square root of 16 is 4. Now you'll see sometimes one will be easier than the other. If you were to try to simplify this thing down, it's going to be a bit of a pain because square root of 2 is not a perfect square. So it's going to be easier here to multiply first, then take the square root. On the first one, it's easier to take the square root and then to multiply. Both of them are fine. So depending on your problem, know that you can do it in either order. That's completely up to you. Some problems are easier in one order, some are easier in the other order. So take your pick based on the numbers in your problem. So let's look at a few. Okay, so here's the first problem that I have. I'm going to go through and I'm going to go ahead and multiply these because we're talking about cubed root. 25 is a perfect square, but it's not a perfect cube. So if I go through and I multiply, now I'm not actually going to multiply completely. I'm going to leave them kind of split up. I could split 25 into negative 5 times negative 5, and I've got a group of 3 negative 5s. Now I needed a group of 3 because it was cubed root. Okay, so let's keep simplifying. Now on these, we're going to assume that all of our values are positive, so you don't have to worry about absolute values. Now you'll notice 72 is not a perfect square. What I'm going to do is split it apart. So 72 is 2 times 36, and 36 is 6 times 6. Now I'm looking for a group because it's square root of 2 of a kind. There's my perfect square. 6 times 6 or 36. I can pull out a 6. The 2 doesn't have a group to pair with, so it has to stay inside the square root. Now I still have to deal with the x's, but square root of 72 is 6 root 2. Now with my x's, I've got 3 of them, so I can pull out a group of 2. I'm pulling out one group, but I've got 1 left inside. Now here's the shortcut. 2 goes into 3 one time with 1 left over. Now we're going to do that on a few others. I always like to rewrite these because I just feel like they're always a little messy when I first do them. So there's my answer. Alright, now I'm doing cubed root here, so I'm looking for a group of 3. Now I'm not sure exactly how to split this up, so I'm just going to split it up as 4 and 20. Now that means 4 is 2 and 2, 20 is 4 and 5, and the 4 can be split up again. Now looking at this, here's a group of 3, so I can pull out a group of 2. Now I needed a group of 3 because it's cubed root. The 5 and the 2 have to stay inside, and 2 times 5 is 10. So 10 has to stay inside. Now with my ends, 3 goes into 5 one time, so I can pull out 1 with 2 left over. Now if you were to write it out, I've got one group of 3 with 2 left over without a group. That's what stays inside. So 2n cubed root of 10n squared. All right. Alright, so let's do one more of these. Alright, so I've got some stuff multiplied together here. Now I'm going to go ahead and multiply before I simplify down. So 54 times 5, and you can do that in your calculator, is 270. X to the 5th, now remember from the exponents, when you're multiplying, you add the exponents, y to the 7th. Okay, now this is cubed root, so I'm looking for a group of 3. Now I like this because I know this is 27 times 10. 27 is nice with cubed roots because it's 3 times 3, that's 9, times 3 more. So I like seeing a 27 because there's a group of 3 3s. Now the 10 is 2 times 5, which isn't really helpful. There's no groups there. So I'm not going to be able to pull any of the 10, the 2 times the 5 out. Okay, so I can pull out a 3. I'm going to take care of my x's and y's in a second. Cubed root of 10. The 2 and the 5 are left inside. 2 times 5 is 10. With the x's, 3 goes into 5 one time with 2 left over. And 3 goes into 7 twice. Oops, I put it in the wrong place. Sorry. 3 goes into 7 twice with 1 left over. I always feel like it's kind of a mess here, so I like to rewrite it. Now I am going to leave a little space here because I don't want the 2 and the 3 to look like they go together, because the 2 is an exponent here, the 3 is a cubed root, so I kind of leave a little space so that it doesn't get all jumbled together. Alright, so that is 7.2a. Now I'm going to do the podcast separately, but in class we are doing 7.2a and b together.